Hello everyone, my name is Prashant Mohan Thakur and I welcome you all to the fourth class of Division and Remainder. So again, we'll be doing some questions today, and from these questions we'll be learning out some concepts. Okay, so let's start. So we can say, let's take this question. Find the sum of all two-digit numbers that leave a remainder 3 when divided by 7. Again, the question says to find the sum of all the two-digit numbers that leave a remainder 3 when divided by 7. So again, we need to see the question once more. It says sum of all two-digit number. That's the first thing, and then the remainder 3. Okay, divided by 7. So two-digit means the least two-digit number is 10. So if we divide it by 7, we get a remainder of 3. Okay. The next, we can check for 11, 12, 13. We won't get anything, so we can we keep doing this and we get 17. If we do it again by 17, we get similarly again. You see, it is 10, it is 17. So can we check for 24? Again, see. So what we can see over here, that it is moving with a common difference of 7. 10 plus 7 plus 7, we can check for plus 7, and we can keep doing this, and we will see that all these number will give us the remainder what we are looking for, the desired remainder. It will give us 3 again. All of these would be giving us the same thing. Okay. Now again, what it is saying, the question here, it is asking that we have to find the sum of all the two-digit number that leave a remainder. So we have to find sum of 10 plus 17, something like that. That's what we need to do. Okay, that's what it is asking actually. You know, it seems here that this question is of division and it requires some high-end division concept, but if you look properly, it is not. It's just a normal question wherein, if you see over here, if we try to find some numbers, you know, see, we had 10, 17, 24, 31, 38, and okay, so the last two-digit number is 99, but we know that 99 would not help us because the remainder over here would be 1. So where do we have to stop? We can look for, we can go over here, we can say 13 plus 7, 91 should be 91 plus 3. This should be the last two-digit number upon division by 7, which would give us a remainder of 3. Okay, so what we can see over here, we have a 10, we have a common difference of 7. Now we need to find, first of all, we need to find the number of terms. If this is what, we can do this as well. Otherwise, you can just simply find from here as well that how many numbers, because what we have done over here, that this is 17 into 13 plus 3, which means that this is the 13th number. You know, see over here, this is 7 into 1 plus 3, which means it's the first number. 7 into 2 plus 3, which means it's the second number. 17 into 3 plus 3, 17 into 4 plus 4, 17 into 5 plus 3. So we see over here that just because we have multiplied it by 1, it means it's the first number. We have multiplied it by second, so it's the second number, and this trend keeps going on. So we can see over here that we are multiplying, in order to get this 94, we are multiplying 13 into 13. So this is the 13. So the number of terms, you know, we can say like the number of terms is equal to 13. Now what do we have to do? We need to find sum of AP. This is an arithmetic progression, sum of AP. So it should be n by 2. we should have a1 plus an. So what do we have? N. How many? What's the n we have? N is 13, then by 2, and a1 is 10, and an means this is the an is 94. So we have 13 by 2 into 104. What means is, if you multiply 2, okay, so 13 to 26, this should be the answer. Again, see, it's a very basic thing. Just what we have used is, we have to use some sort of common sense. We need to know about the common difference, and the first thing, which is very important, that we should not get scared that, oh my god, now we have to add sum, we have to do sum of 10 plus 17, and you know, of course that's another way you can do it if you have enough time, and if you have nothing to do in examination, you can do it, but that's not advised at all. You can use concepts, and you can do such questions in a very quick span of time. Okay, so now let's do the second question. So this would be the second question, and then we'll see what concept we can learn from this as well. So 3 numbers leave remainders of 43, 45, I'm sorry, 47, 43, 47, 49 on division by n. The sum of 3 numbers, the sum of 3 numbers leave remainder as 9 when divided by n. So how many values can n take? That's the question. I'll just read it back for you once again. So 3 numbers, there are 3 numbers, you can say any 3 random numbers which have been divided by n. Okay, see, which have been divided by n. There are any 3 numbers, and these are the remainders, 43, 47, and 49 on division. The sum of 3 numbers, again, if we add these 3 numbers, so if we add the sum of all these 3 numbers, and again we divide it by n, it leaves a remainder of 9. Again, think, do not get confused. First of all, there are any numbers which is not given over here, that's hidden, which has been divided by n. These numbers upon division by n have left remainders as 43, 47, and 49. Now again, when we add these remainders and again divide it with n, we get 9 as a remainder. So how many values can n take? That's the question over here. Okay. Now, before we go for solving this question, we need to understand the concept. That what is the concept? Because by the first look, this question looks quite impossible sort of thing, but it's not that. We have to use basic properties of what you may as a remainder, and then that would be fine. Okay. So if you would have gone through my last videos, I would have I have said there that remainders can be used multiple times. Okay, if you remember, I said, okay, multiply 132 by, let's say, 5. So you can split 100 and then what you can do, you can find remainder from here. If find remainder, so you can see over here 521 and then 522. You can say 2 is the remainder, isn't it? Because the numerator we can only use it once, but numerator, see, I've used this with here as well and here as well. So the remainders can be used multiple times. Okay. Now if we go a step ahead of this, okay, if we go a step ahead of this, we can add some more, or we can get to know about some more feature about it. So let me explain this to you. Now let's say there are any three numbers. For an example, let's say 19, 13 and 12. Any three numbers, okay? And for an example, we have divided it with 7, you can say, okay? Let's say we need to divide it with 7. So 7, 12, we get remainder as 5. We get 7, 13, we get remainder as 6, 7, 19. So we get again as 5. So let me make it a different number. Let me make it as 18. 18. Just to explain you, otherwise these two numbers would look alike and you may get confused. So I've just taken another number, okay? Now what we are trying to look over here is, now see, so just remember these things, that the remainders upon division by 7 of these numbers are 5, 6, 4, okay? Now if I try 12 plus 13 by 7, what do I get? 25 by 7. And what do I get as a remainder? I get remainder as 4, okay? Now add two numbers and then take the remainder, okay? See, it is the same as it was before. Now again, understanding, if we add two numbers and then take the remainder, it's the same as we took remainders and then added, okay? I'll explain you. See, over here what we have done, we have not taken the remainders, we have just added the numbers, and here I have taken remainder specifically for the purpose of explaining you. So over here you will see that the remainder of 12 is 5. See over here. And over here as well, if you take the remainder, it would be 5 itself, and for 13 it would be 6 itself. Okay, so what I mean to say is the remainders, and this is a very important concept as well, that remainders are consistent for addition, subtraction or multiplication. It would be the same for subtraction as well. It's not going to change at all as long as divisor is same. You know, till the time divisor is same, we can add the two numbers and then take the remainders, or add the two remainders. Once again, I'll repeat, as long as the division, as long as we are dividing it with 7, it doesn't matter if we take remainders first and then add, or we add the numbers and then take the remainders. It's not going to make any difference. The remainders or anything is not going to change at all. For example, let's 18 plus 13 by 7. So we have 31 by 7, we get 4 over here, okay? But if we do, if you want to check individually over here, so we'll see that the remainder, it would be 4 over here, and for 13 it would be 6 over here. So that's what I'm trying to do. Let me explain this to you in another manner again. Let's say 450 is divided by 7, for example. So 45 into 10 we can say is divided by 7, okay? So what we can check, we can 3 over here remainder and 3, so we can take 9 as the remainder over here. 9 is the remainder, but again we know that remainder is less than the divisor, so we'll subtract it. 9 minus 7, we get 2 as a remainder. If we do this way, if we do the other way as well, it's not going to make any changes. 7 6 42, 3 0 7 4 28, so 2. So this 2 and this 2 are equal. It does not make any difference how you do it, isn't it? And it's same for multiplication or multiplication and addition and subtraction, okay? So this is the concept. The concept is that remainders are consistent. Till the time divisor is the same, you can add, you can subtract, or you can multiply, and it will not make any difference, okay? See the you can refer to the example of 450 if you have problem understanding it, okay? So now again, let's go to the question. So it says there are three numbers that leave remainder 43, 47, 49 on division by n. Now again, see what we are doing. We are dividing some number, and we are getting remainder as 43 in one case, 47 in another case, 49 in another case. So can we consider this number as be, let's say this can be any imaginary number, not imaginary like means you can imagine. These are natural number, of course. So we are dividing it. So let's say over here, so this number, can we write it over here, n into k You know, this is how we do divisor into dividend plus remainder. No, how we have got 100 and so 43 plus 47 plus 49 exactly. Okay, now again, if you're confused why we have added it up, because these three are the remainders. So even if we again, if we 43 plus 47 and then we divide it, it's not going to make a difference. If we divide it by n, the remainder would be the same. Okay, for that purpose we have done this. So this is our equation number 1, we can consider this as. Okay, that's one thing. Now second thing, it says that the sum of three numbers, again, leave remainder as 9. Okay, the sum of three numbers leave remainder as 9. So can we consider over here something like it was k, so we can consider n into m plus 9, isn't it? Now this is equation 2. So can we see n into k plus 139 equal to n into m plus 9, or if we want to take equation 139 minus 9 is 130, so it would be n into m minus k equal to 130. Now you understood this case or not? Just look over here again. Three numbers leave, again, read the question. If you have any, if you want any reference regarding what is being done, the best way is to read the question. So three numbers leave remainders on division by n. The sum of those three numbers would leave remainder as 9. But see, again, the numbers are still the same. That's why we have taken it as equal. Okay, let's, for an example, let's say those three numbers would be, just I'm giving an example, 55, 82 and 71, just for an example, that, and it is being divided by some number which gives remainder 43, 47 and 49. Okay, now even the sum of these three numbers when divided by n, again it is being divided by n itself. Okay, it would leave the remainder as 9. So we have taken, because this number over here, what we have taken in the first situation, and this number would be equal if you add it up. Okay, so that's why I've taken it over here. So now what we can refer from here, what we can refer is n into m. So can we see over here, let's say if this number 7, let's say x minus y equal to 30. What does it mean? It means that this particular thing is a factor of 30, isn't it? I'm just giving you an example, don't take it as a realistic term, isn't it? So n has to be a factor of 130. Okay, isn't it? It means from here, if we take refer, it means n has to be a factor of 130. But again, we need to check one more thing, that the remainders are this, isn't it? So we know that remainders would always be lesser than the divisor, isn't it? Remainders would always be lesser than the divisor, and that's why these are called remainder, because there's no point being divided, there's no point dividing it from there. Let's say 2 into 7, so 2 into 6, 7. Now see, remainders, this would be always less than the divisor. So we see that the one of the remainder is 49. So it means that n is anything above 49, and also n is a factor of 130, which means n is more than 49 and a factor of 130. Look here. So if you see in this way, so what are the numbers that are more than 49 and that are a factor of, so we can see over here, it would be 65 and it will be 130. There are three numbers. Okay, I'm just repeating this for you. There are three numbers which leaves remainder 43, 47 and 49. Okay, so we have remainders. Okay, let's say 49 on division by n. These are being divided. There are some numbers which are being divided by n into something. Okay, and we're getting 43, we're getting 47 and 49. Divisor is the same. This is changing, doesn't matter. So what we can do, we can write all of these combined into an equation is n into k n into k plus 139, isn't it? Because see, this k would keep changing. Let's say for example over here, this k would not be same for all, so we want this k to be constant for all of these. So what we can do this way. Okay, so we have this something, this is one equation that we have, and saying the sum of three numbers, leave remainder as 9 again. So sum of three numbers, we can say n sum of three numbers, and we again, let's say video. So what we get remainder as 9, n into m plus 9 equal to 2. Now these two numbers are equal, you equate it from here. So m minus k equal to 130, which means n is a factor of 130. A factor of, what are the factors of 130? If you have gone through my factors video, I've done that in number system itself, I believe. So 2, you will have factors 2, you have 65, you have 1, you have 130, you have 10, you have 13, you have 5, and 5 you have, then you have 26, then you would have, and then there would be many factors. But what we need to look for, factors more than 49. Why? Because remainders are always lesser than divisors. So for above 49, it's very simple. It has to be 65 and 130. So that's what we have taken over here. Okay. So this is very good question based on concept. The concept is very clear that remainders, I'm writing it over here, that remainders are consistent for addition, subtraction, and multiplication. I have given you an example as well. You can refer to that example for understanding this, that nothing changes. Okay, so let's stop here and I want you to go through it and revise it, and in our next video we will be doing some other questions and some good concepts as well. Okay, so thank you for being on Competition Valley. My name is Prashant Thakur, and